Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and before I go on hiatus with 3D collisions again, there is one last thing that I'd like to do. So, sometimes when you're making games, you would like for some objects to be able to detect collisions with certain things but not others, even though everything's still part of the collision world. And to do that, it's actually pretty easy. We only need to write a few lines of code to do this. And the little bit of math that I'm going to be making use of here is going to be something that was slightly less culturally relevant than last time I talked about this on this YouTube channel than it is now, and that is going to be masks. Because I like to stick this picture in my videos, there's going to be a little bit of binary math involved today. It's not going to be anything insane, just a little bit of binary and, binary or, maybe a flag or two. We're not going to be doing anything super weird with like unary operators and bit shifts and that kind of thing. This hasn't been a problem in the past when I mentioned it in videos, but well, there's your content warning. At some point in the future, I'd like to make a video just on binary operations, but that day is not today. To demo this, I'm not going to add anything new to this collision test world. I'm just going to use what we have already. So there's this special tree in the middle. I can walk into it. I can throw a tennis ball at it and have it get. If I can actually hit it, there we go. I can throw a tennis ball at it and have it get stuck, just like all the other trees in this collision world. And for this demo today, I'm just going to be changing that. The player is going to be allowed to walk through the tree, and the tennis ball is still going to get stuck to it. And everything is still going to be part of the same collision world. We're not going to be selectively deactivating objects when we do certain collision checks or anything like that. That would be hugely expensive. We are just going to do a little bit of math to figure out what can and can't collide with other things. So if I were to go into the 3D collisions base project, this is the base project, not the test world. This is the one with like the abstract shapes that are doing things with abstract shapes. I'm just going to add two more values to the constructor of the call object struct. So that is going to be, one is going to be a mask and two is going to be a group. And we can assign those as instance variables, and that's step one. So if you've ever used the bullet collision system before, this is probably going to look pretty familiar. In bullet, objects have a mask and a group, and that determines what can detect collisions with what. Mask is a bit field which determines what other things can collide with me, and I'm going to put that in a comment just to keep them straight. And group is it's also a bit field, although it usually only contains a single bit that's active. Group is for determining what I can detect collisions with. Maybe I'll say what masks I can detect collisions with. So just to keep the vocabulary straight, when I go over to the demo world to show this off, I'm going to be referring to the different types of collisions that can happen in the world as the group. And I'm going to try to only say the word mask when I'm referring to the group or multiple groups that another object is trying to detect collisions with, just to keep the terminology straight. Okay, it's me from the future here. The responsibilities of the mask and the group in the collision system are a little bit nebulous. If you didn't get what I said just now, I'll try to elaborate on it a little bit, and you'll see examples later. The mask is the field that is relevant to the objects that are static in the world and that are being checked against by other things for collision, and the group is the field that is relevant for the objects that are doing the collision checking, which is to say that when the player moves around the world, or when an NPC tries to walk around the world or something, the player is going to check their group against the mask of all of the other things in the world. Most of the times, but not necessarily always, objects that are moving around the collision world only belong to one group. That group might be the player, it might be magic spells or that kind of thing. Again, you'll see examples of this later. And objects usually only belong to one group, whereas their mask can contain flags representing multiple groups, so objects can be solid to multiple different kinds of things that are moving around. I'm sure there's a way that one could extend this metaphor to the pandemic and social responsibility, but I'm not going to dig that far for this one. Anyway, if you are a little bit confused by my first explanation, hopefully that clears it up a little bit, and again, we will be spending most of the second half of this video playing with examples. I'll get to the implementation in the test world in a minute, but for the time being, I only need to write a few more lines of code. So in the check object method, right below where it says object equals equals self return false, just so that you can't detect collisions with yourself, because that would always return a positive. We can do a little bit of binary math and say self dot mask binary and objects dot group. Remember, the object that is passed to this method as a parameter, this is the object that is doing the collision checking. So if you're the player and you're walking around the world as the player and doing collision checks as the player, all the other objects in the world, the floor, the trees, the whatever, those are going to be objects which are calling the check object method on the player. So in this case, self is the tree and object is the player. And we are going to do a bitwise AND between the tree's mask and the player's group. And if this equals 0, that means that there are no shared bits between the player's group and the tree's mask, and therefore collision should not be detected. We are going to return false. And if the tree's mask does include the player's collision group, that means that the player should be able to check for collisions against the tree, and we are going to also we're going to proceed from there like normal. So we can also do something like that in the raycast. Rays are shapes. Only objects have a collision mask and a collision group. Rays are just shapes that don't have any information about the world. So we're going to want to pass a group to the raycast method as a parameter. Also, by the way, if you do not really care about any of this, but you want to just include this little bit of code anyway, because it's essentially free, it adds virtually no overhead at all, and it can be useful in some certain situations. You can set default parameters, masking group to 1, and that will allow everything else to proceed as normal, and you won't have to think about like assigning values to the masker group or anything like that. And we can also do that in the raycast function here. Anyway, we can say if self.mask logical and bitwise and, wow. Some people don't care to differentiate between like mathematical bitwise and logical true or false boolean and. I do, because I think it's less confusing about what you're talking about. But anyway, we can say if this expression equals 0, return false. That's pretty much the same as line 9 up here in check object, except instead of taking an object as an input parameter, we're just taking the group as a value that's just being pushed onto the call stack without any objects. All right, so that's call object. That's the changes that we need to make to call object. Next, call world. Objects like checking for collision, checking to see if the two masks intersect. That's just handled right here. We don't need to do anything else. For raycasts, since you generally don't raycast against individual shapes, we're going to also need to include a little collision group data in the world's check ray method over here. Again, we can assign this default value to 1. Once in a while, you might want to check for collision against a specific object or a raycast against a specific object, but it's not often that you do. Anyway, we can also, the world's check ray method is just going to pass the collision group on, to whatever acceleration structure is going to be working this out. And, of course, that also means that the octree, and in the future, I do want to implement other acceleration structures for different use cases. Other acceleration structures will want to take a collision group that we can also pass on to the check ray, the object.checkRay method down here. Okay. That should be all we need to do for the, to the system. That should be all the changes we need to make to the system. If I were to go to Tools, Create Local Package, Publisher Name, Display Name, File Name. I wish GameMaker didn't like ask you to fill this out every single time you made an asset package, because sometimes I only want to move scripts from one project to another. Anyway, we can hit OK to save this. I'm going to save that as 3D collisions over whatever was there previously. If I were to minimize this and go over to the 3D collision test world project, and if I were to just either import the asset package or just drag and drop it into the IDE to add it, we can add all the collision stuff files that have been changed. We're just gonna overwrite everything. The only thing that's actually changed is call world, but never mind. So if I run the game now, the game will behave exactly as it did before, because all the default collision mask and group data is set to 1. So I can still run into trees. I can still, if I wanted to jump on the trees, I could still land on the trees as I could before. If I were to run into the tree in the middle, if I were to throw a ball at the tree in the middle, everything behaves as it did before. But if I want to get a little bit fancier, I'm going to have to do a little bit more setup, which will allow me to filter collisions based on type. So first, let's define some collision groups. I'm going to macro, and you can use a macro for this. You can use you can use an enum for this. It doesn't really matter. But macro collision group player is going to be one. Macro collision group ball is going to be a second, and because I do want to have more than just 2 collision groups for this demo, macro collision group, let's say ghost is going to be a third. I will get to that later. Ghost can walk through things without colliding with them. We would like to. I'll mess around with that later. So the value for a group player is going to be 1. The value for group ball is going to be 2. The value for group ghost is going to be 4. These are going to be essentially place values in a bitwise mask in a bit field. So the player is going to be the 0th place value, so that's going to be the 1's place. The ball is going to be the 1st place value, so that's going to be the 2's place. The ghost is going to be the 3rd place value, so 2 to the 2, that's going to be 4. You could hard code them like this. That's probably not ideal if you want readability. Some people like to say 1 bit shift to the left 0 places for 1, 1 bit shift to the left 1 places for 2, 1 places. 1 bit shift to the left 2 places for 4. You could also do my preferred solution, and that is going to be using hex notation 0x01, 0x02, 0x04. The first 10 digits of hexadecimal are the same as decimal, but for example, 16 would be 0x10. 32 is 0x20, 64 is 0x40, and it tends to be a bit more readable without having to memorize the decimal representations of different powers of 2. All right, so that's going to be our those are going to be our collision groups. Next, where are our call objects defined? So our floor, first and foremost, we're going to want to assign a mask to this. So remember, the mask is the collective of all of the groups that can collide with this object. So for the floor, that is going to be collision group player, as well as collision group ball. You can bind these masks with logical or. If you wanted the floor to be able to collide with other things, you could logical or other things onto that too. But for now, I'm going to start with the player and the ball. Strictly speaking, the ball will never actually intersect the floor because the ball always goes in an upward direction because of the way that I coded it earlier. But never mind. And the group can just be. It doesn't really matter. The floor is never going to try to detect collision against anything else. It's just going to sit there, and the player is going to detect collisions with it. But if it makes us feel better, we can either assign it to. We can either leave it as the default value. We can just assign it collision group player, which happens to be the same as the default value. You can give it a 0 if you want to ensure that the floor will never try to detect collisions with anything else. That might be a little bit weird. I'm gonna just leave it blank for now. So the trees, most of the trees anyway, the trees are on the periphery. Same deal. We want them to be able to detect collisions against collision group player, as well as collision group ball. And they're also never going to detect collisions against anything else, so we could leave its group argument just the default. because it doesn't matter. Next, thirdly, the tree that's in the middle, I said that the player would be able to walk through this. So its group is simply going to be collision group ball, without including the player's group for its mask, because the player is going to be able to walk through it, the ball will not. And the collision object representing the player. What the mask for the player is doesn't matter tremendously, because the player can't detect collisions with themselves. Neither can the ball, because the player doesn't, the ball doesn't check against the player. But if you want to, you can just give it a collision mask anyway. And for the player, since the player is going to be the one who's doing the collision checking, this is where the group is actually going to be important. Your group is going to be collision group player. And this will ensure that the player is able to detect collisions against things that are responsive to the player. So the floor, the trees, and that sort of thing. Okay. Also, strictly speaking, the binary OR here between the different collision groups when you're building a mask, the number that you get as a result of this expression is the same as the number that you get as the result of just using a plus here. And sometimes I see people using a plus when they're combining masks, but I prefer not to do that, because that implies that addition is the same as binary OR, which it isn't. It's only the same if the if the values don't already include each other in their collision masks, because if it does, you'll end up carrying a 1, and then it's gonna mess things up. Use binary OR, don't use AND. Don't use plus, rather. So, if I were to go into the step event where collisions are checked, where were we? The collision worlds check object, this does not take any collision mask information, that's good. The only other thing that we need to do is okay, so it's in the balls update method. Where is the ball? The ball should be down here. The only other thing we need to do is, when we check a raycast against a world, we also need to supply a collision group for for objects that we are checking against, and this is going to be collision group ball, because this is going to be checking for things that are solid to the ball. And now, if I were to run the game, and that's going to take a moment to start because there's 1,000 objects being added to the world. The ball, you can throw the ball, okay, so that's a good sign, and it sticks to the trees. You can throw the ball at the tree in the middle, and it sticks to the trees. I can walk into the trees around the perimeter, and I can't go through them, but I can walk, and you'll notice that this performs significantly better here, checking for my collision against the tree when I can walk through it, because in addition to filtering collisions, checking to see if the object's mask matches the player's group will also just skip the collision check entirely if the mask is not included in the group. And that can be a small optimization. Although I won't categorize that under optimizations for the 3D collision system, because it's not something that you'll do on purpose unless you already want to filter collisions like this. Okay, that's pretty nice. So if I were to take this a step further, and if I were to play with the collision ghost group, I could, if I were a ghost, I should be able to walk through anything, whether or not I try to jump on it or walk through it or whatever. If I were to go into the step event and say if keyboard check pressed, let's say VK enter. Should I let's go into the player object and say self.isGhost equals false. That's going to be false by default. If you hit the enter key, self.isGhost equals not self.isGhost, so we're just going to negate that. And we can also say if self.isGhost, so if when you hit the enter key you turn into a ghost, let's see, it should be objects.group is going to equal call collision group ghost, else self.object.group is going to be equal to collision group player. And if I were to just like draw something on the UI, I guess I can do that too. Is the draw GUI event in use anywhere? It is not. Where are we? Draw events. It is self.player, right? It is. So this is almost going to work. There was one thing that I deliberately did not do not too long ago, and you may have spotted it because I want to show something happening here. Let's see. Is ghost a 0? So we are not a ghost right now. We can still collide with everything. We can still walk through this tree because that's impervious to the player anyway. I can jump up and down and land on the ground. If I were to hit the enter key, I'm gonna start falling through the floor because the and I'll hit tab just so that I stop falling. The player does check for collision against the floor, and earlier I did not make the ghost part of the floor's collision mask. You probably want to do that if you were to do such a thing. This is not like the only way to make a game, but just to provide another example of what you can do with this system, let's make the floor. Let's make the ghost player respond to the floor as well. So collision group ghost, and the floor is going to be the floor's mask is going to contain all 3 collision groups. So so nothing can ignore collision with the floor. And if I were to run the game now, and this is going to take a few seconds to start because again we have like 3,000 trees that we're adding to the world. The player will still be able to detect collision with the floor, but the player will not detect collision with the trees. And also, by the way, if I hit the enter key, you should notice the red part, like the step event part of the debug overlay at the top, get much smaller because the player is not actually detecting collisions with any object, and we're not doing any math that figures out if we can walk through trees or not. So I can like jump / fly / when you jump there's no code detecting if there's actually anything below you, so you always do it. If I were to do the raycast ball still sticks to the trees, but it's just me that does not. And if I were to hit enter again, I return to the world of the living, and we can collide with the trees again, but not the one that's still impervious to the player because that hasn't changed. Okay.
Hey.
I should have like saved this video for Halloween or something, but I think Halloween is like on the the polar opposite side of the calendar from when this video is going up, April and March. All right. Let's see. Is there anything else I wanted to do? This should be pretty much it. I do make use of filtering collisions on occasion when I'm doing game dev, allowing the player to collide with certain things. But for example, like I think the example that I used earlier was like a magic force field, so that you could like the player could like throw a ball through a force field, but the player couldn't walk through the force field. Which, come to think of it, is kind of reminiscent of some parts of like Portal, which had the force field to prevent you from taking the companion cube with you. Anyway, things like that you could use this for. If you want to do the opposite, you could have the player cast a spell and have it pass through a wall that the player is solid to, or you could cast a spell and have it stop at something that is like an invisible wall outside like the boundaries of a battlefield or something, so that you can't like cast spells where you're not supposed to. But anyway, filtering collisions is fun. If you used another game engine like Unity, you might have done something like this without realizing it. Unity has a similar system for filtering collisions, except instead of calling it like the mask and the group, it calls I think it calls them physics layers. And objects on certain physics layers can only detect collisions with objects on certain other physics layers. It's the same principle, although it's set up a little bit differently. The like what can interact with what is a global system. Individual objects don't have their own collision masks. Individual objects just refer to a global mask / group system. The physics engine that Unity uses is PhysX, NVIDIA's PhysX instead of Bullet. I don't know if the physics layer is an NVIDIA term or a Unity term.
Hey.
Honestly, I kind of wish that GameMaker's built-in collision system, GameMaker's built-in 2D collision system did something like this. To my knowledge, it actually does not. And I could see arguments being made as to why that would be a beneficial thing to have in GameMaker's collision system. But on the other hand, GameMaker being oriented towards beginners, maybe that's not a huge deal. So I'm going to commit changes to both of these projects. The 3D collisions base project can be added collision groups and masks. This is going to be its own release. This is going to be 0.2. This is going to be 0.21. Skipping 20 because 20, like week 20 was the demo, and I want to keep them synchronized. And if I were to also go into the 3D collision world, this was a little bit more actually. This was added collision filtering to the demo. Oh, did I not publish those last changes? Hang on. So, that's going to do it for me for now. This is going to be the last 3D collisions video for a little while. Hopefully the hiatus won't be too long. There's still other things left for me to do, but I want to spend mental energy on other things for a bit. If you want to see the code for this, look for the repositories that I just committed the changes to down in the video description. I have a Patreon, so if you want to contribute towards these videos being made, look for links to that in all the usual places. You could see some fun things like your name in the credits or a preview of my future plans that I like to post about once a month, and if you wanted to pledge, I would definitely appreciate it. Otherwise, I try to post about 2 game dev videos a week. One tutorial like this, as well as one Let's Make a Game. Currently Bullet Hell, so if you're interested in any of that, feel free to subscribe. Otherwise, I hope you found this useful, and I will see you all later. Special thanks to DJ Gibbles, Edward Holt, GameMaker, Gunnar Clovis, Posho, Sindra Larson, Squarecrow, Then Nothing Happened, and Zenjamin for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.